Alright, so we're going to continue with 3.7 with the absolute value, but we're only going to, even though the directions will say to graph, okay, we're only doing the transformation. The directions will say compare, only compare, which is really describing the transformation. So there'll be two sets of problems, but let's review first. So these are, remember, like our original like parent graph would look like that, and then you could add in, you could put a negative, you could put a letter in front, or excuse me, a number in front. You could add, let me back up. There's all kinds of stuff we could do. You could put a number in the front of the x. You could add or subtract a number after the x, and you can add or subtract something at the end. So remember that, how do I want to put it? Outside the absolute value means things are going to change in a vertical direction. Excuse me, yeah, that's outside. And then inside the absolute value, it's going to be horizontal, but opposite of what it would be like if it was vertical. So let's go down the list. Hopefully I have enough room, but I'm going to erase this for right now and come back to that. So the letter A, if there's a number in the spot where the A is, that's going to be a vertical stretch if greater than 1, or a vertical shrink if between 0 and 1. We say 0 and 1 because if there's a negative in the front, it's something different. So basically you're looking for just a fraction in the front. Okay, the B, so if there's a 2x or a 1/2 x or something like that, it's going to be a horizontal stretch if between 0 and 1, and it'll be a horizontal shrink if greater than 1. So remember what I wrote over here on the side. Everything in the middle or in the inside is horizontal, but it's opposite. So it's a stretch vertically if it's greater than 1 for the A is on the outside, but if it's greater than 1, it's a shrink on the inside, so it's the opposite one. Okay, we'll do some examples of all this, but the H is a horizontal translation left or right. Remember, you go opposite of what it would appear. and then k is a vertical translation up or down. All right. Now, if there's a negative sign, let me just do it like this. If there's a negative in front of the A, then that's going to be a reflection over the x-axis. And if there's a negative in front of the B, then it's a reflection over the y-axis. Okay. So again, this wouldn't be a bad kind of picture to screenshot, copy down on a separate sheet of paper. I know I suggested it the other day, but this would include, so a couple things that it'll look slightly different than the other day, because the other one was involving like function notation, where this is an absolute value, but they're identical in that it's either inside or outside an absolute value or inside or outside parentheses from the other day. Okay, but they're consistent in terms of if there's a number being added at the very end, like where the k is, they're always going to be a vertical translation up or down. Okay, so let's go over what the problems will look like today. Negative out in the front of the A, so down here at the bottom, negative in front of the A. Well, in this one, where the B is, it's in front of the X, but on the inside. So the B says horizontal stretch if between 0, 1, or horizontal shrink if greater than 1. I would write this screen out on a piece of paper and have it in front of you while you're doing the problem, so that you can say, oh, like, what's different is the K. And then you look over here, okay, K means vertical translation up or down. And then you can go with that. Okay, what's different? Well, there's a B. All right, the B says horizontal stretch if between 0 or 1, horizontal shrink if greater than 1. Okay, and then I suppose I might have enough room in here to do the reciprocal. Okay, so write this out, have it in front of you while you're doing the problems. It'll help you memorize it along the way, and you'll have like a map to say, okay, this is where this is where that is, and you'll begin to get these done a little bit quicker, and you'll remember them a lot better. Okay, all right, have a great Friday, and we will see you on Monday. Be 2 sets. One of them I think might actually be a little harder than the other, but let's see. So it's going to tell you something to compare it to. So let's say I had that one, and then the second one is like that. So you're basically just looking for what's different, no matter what type of the problem is, like what's different from the first one to the second one. Well, in this one, what's different is there's a 2 there. The x plus 4 is the same, so I don't care about that. So this would be a vertical translation up 2. So anything that's adding or subtracting on the outside is always a vertical translation. If it's positive, up. If it's negative, down. Okay. So if we had one like that, what's different? Well, there's a negative sign out in the front. So that would be a reflection over the x-axis. Okay, so if you go back, there isn't like a number there, but technically there's a 1, so that is a negative in the front. Okay, so if we had one like that, okay, what's different is the 3. Okay, so that's where, so that's greater than 1, so it's going to be a horizontal shrink by, and here's a difference that I didn't have room to write on the other one. When it's on the inside, a shrink, we do the reciprocal. Okay, so if it was, I'm going to do kind of the same like problem. Okay, so what's different is that 1/4 right there, so it's kind of the same as the 3, just a different number. But since this one's between 0 and 1, it's a horizontal stretch by, and again we're going to do the reciprocal, so it would be like 4 over 1 or just 4. Okay, so that's one kind of change. Okay. So the first, well, let me do one more like that. Or, you know, x plus 4, x minus 2. Like you'll have something that, but could have, you'll have a couple like this. Okay, where it's, okay, what's different? Well, I have a 2 and I have a minus 1. So the 2 in the front, that's a vertical stretch or shrink. So it's a vertical stretch by 2. And then the negative 1 at the on the outside at the end is a vertical translation down 1. down because it's negative. So on the first 6 problems, you'll have like an x, x minus 3 at the beginning. We'll compare to. The second set, it's not all that different, and really you could think about it the same, but they're all going to compare to the parent graph. So it's not going to list 2 of them, but in the directions it says compare to f of x equals opposite value of x. So basically anything that's not the x is what's being added in the problem. So you're not going to see 2 functions like we did on the other one. So okay, so what's kind of put into the problem is the negative sign and the 5. So we have the negative sign there, and we have the 5 there. So the negative sign in front of the x means reflection over the y-axis, and the 5 means it's being added. Anything that's being added or subtracted is a translation. And remember, on the inside we do opposite, so that positive 5 would mean go to the right, but this is going to be a translation to the left 5. We forgot to write in horizontal translation. Okay, so all the problems again, you are just writing the translation or the transformation. It's either a translation, a reflection, stretch, or shrink. Okay, don't graph them. It's going to say to graph. You don't have to graph them. Okay, so I would honestly, like I said it earlier,